Hello friends, today in this lecture we are going to discuss RS configuration. So RS configuration is very essential part of stereochemistry, particularly in optical isomerism. So in the first part of this video we will be discussing about the importance of RS configuration and where exactly do we use it. So actually what is it good for? And in the later part we will discuss how can we determine RS configuration. Okay, so if you remember, our discussion started in stereochemistry with geometrical isomerism, where we discussed about cis-trans isomerism and EZ isomerism and syn-NT as well. So whenever we have any part of a compound which can show geometrical isomerism, there we can assign configuration to geometrical isomers. These are the different configuration we can assign. Okay. So similarly, when we come to optical isomerism and when we look at the chiral carbon, then chiral carbon can show two different type of configuration. Okay, so I am taking an example of butane 2-ol. So if we draw one of the structures of butane 2-ol, and this is the structure. Okay, so this OH is coming out of the plane and H is going into the plane, and these two are in the same plane. So the another configuration of this molecule will be the mirror image of the previous one. So I'm just drawing the mirror image. Okay, so you have mirror image over here. So both are chiral center, and we can have two different configuration. Okay, so to assign unambiguous configuration to these two molecules, we resort to RS configuration. Okay, so in this butane 2-ol, both are butane 2-ol, one will have R configuration and one will have S configuration. So basically we can conclude here the importance of RS configuration and where it will be used. So RS configuration is used to define uh, configuration or arrangement of atoms configuration around a chiral carbon. Okay, so this R stands for rectus, which is a Latin word, and it means right, and S stands for sinister, which means left. Okay, so now we are done with the first part of the video, where we can understand that what is the importance of RS configuration and where do we exactly use it. And the later part is important, which in which we will discuss about how to determine RS configuration if we have a chiral center in a molecule. Okay, so how to determine RS configuration? So for that we need to follow certain rules and steps. So I have already listed down the steps which are required to follow in order to get RS configuration. So these are the steps we need to follow. So step 1 is to assign priority to the groups or atoms attached to chiral carbon. And how can we assign the priority? We will follow the same route which we did in EZ isomerism. So we will follow CIP rules here, Kahn-Ingold Prelog rules, to determine the priority. Okay, after setting the priority to the groups, we will rotate the molecule in such a way so that the least priority group goes behind the plane. Okay, and after doing that we will check the sequence of other priorities. So if the sequence is clockwise, then we will say that it has R configuration, and if the sequence is counterclockwise, then we will say that it has S configuration. Okay, so R, you need to remember this. Okay, so clockwise means R configuration, and anti-clockwise sequence or counterclockwise sequence, then S configuration. Okay, so we can understand this with the help of model, that what exactly we are going to do. So this is a chiral carbon which is attached to four different groups which are shown by four different colors. And let's assume that this white group is the least priority group. So what you need to do, that place the least priority group behind, okay, and see the sequence of 1, 2, 3. If sequence of 1, 2, 3 is anti-clockwise, then it is S configuration. If it is clockwise, then R configuration. Okay. So we will take example of butane 2-ol only, and we will determine the RS configuration for that. So first step is to give priority to the groups. So let's follow the CIP rule to give priority. So OH must get priority 1, C2H5 2, methyl 3, and hydrogen 4. And here 1, 2, 3, 4. So we are done with the first step, giving priority to the group. Next step is to place the least priority group behind the plane. So this is the least priority group, hydrogen, and it is already behind the plane. So we need not to do anything for that. Now we have to check the sequence of other priority. So here, if you see the sequence 1, 2, 3. So we go like this, 1, 2, 3, and here the sequence is 1, 2, 3. So this one is counterclockwise. So if it is counterclockwise, then it is S, and this is clockwise, so R configuration. So this is how we can determine RS configuration for a chiral carbon. So let me take one more example which will be a bit twisted, different from the previous one. So I'm taking again one chiral carbon, okay, and in this chiral carbon I will not place the least priority group. I will not place the least priority group behind the plane. So suppose I take this molecule, okay, any molecule which has chiral carbon. Now if you assign the priority, then fluorine must get first priority, then oxygen, then carbon, then hydrogen. So we are done with the first step. The next step is to place the least priority group behind the plane. So least priority group is not behind the plane. So either we can rotate the molecule so that H goes behind the plane, or we can adopt a different methodology. So what I'm doing here, that I'll exchange the position of hydrogen and OH. So if I do so, then we get a different structure which will be FOH. The position of fluorine and CH3 remains same, but flow oxygen and OH group are interchanged. Here you have H. Fine. Now, what will be the configuration of this? So this is 1, this is 2, 3, and 4. And if we check the sequence of 1, 2, and 3, then this sequence is clockwise. So we can say that it has R configuration. So if this molecule has R configuration, then what will be the configuration of this molecule? So we can understand this with the help of model. So if we check, these two structure represents the same molecule. So here these two molecules are same. They are completely superimposable on each other. They are completely superimposable. Correct? So these two represent the same molecule. Now what I'm doing, I'm taking one of these and replacing two bonds, exchanging two bonds by breaking two bonds. So we will replace blue and yellow, and we can see now that these two are mirror image. So we can conclude here that if we change two bonds, then we will get the mirror image of the original structure. So basically what we can say here, that these two are mirror images. These two are mirror images. So if they are mirror images, then it has R, so it will have S configuration. So we can understand this from butane 2-ol structure also, that S is this configuration and its mirror image is R. So we can remember it like mirror image of S is R, mirror image of R will be S. So the similar thing we have to do. So now we can understand, even if the least priority group is not behind the plane, then we can do the exchange and find out the configuration of other molecule after exchanging, and then we can get the configuration of original molecule. So I hope you find this video helpful, and you could understand RS configuration. Thank you.